Hey everyone, can I get a quick mic check?
Loud and clear, Stu.
All right. I'm Stu Keach. I'm the Vice President of Dragon here at SpaceX. I've been at SpaceX for about 10 years and I've led the Dragon program since 2021. And it's been a busy year for us this year in 2024. We launched the Axiom 3 mission back in January. In February, we launched the Crew 8 mission up to ISS and brought Crew 7 home. And just earlier this week, we had a successful conclusion of the CRS-30 mission and a port relocation of the Crew 8 Dragon capsule up on ISS. With those operations concluded, I'm excited to announce that Polaris Dawn is the next major operation for the Dragon program. Right now, the whole team is driving towards a launch date in early summer of this year, and we're super excited to chat with you all about mission design and overall objectives. We have the full crew and some SpaceX folks on this event right now and want to turn it over to them to introduce. Jared, if you maybe want to start.
Sure. Great to be here, Stu. Big day for sure on May the 4th. And my name is Jared Isaacman, Commander of Polaris Dawn, and looking forward to speaking with you all today.
And hey, my name is Chris Trigg. I'm manager of the spacesuit team here at SpaceX.
Hey everyone, I am Anna Menon, and I am one of the mission specialists as well as the medical officer on the Polaris Dawn mission, as well as a SpaceX engineer.
And hey folks, this is Sarah Gillis. I am also engineer at SpaceX and the other mission specialist for the Polaris Dawn flight.
And I think we know Kid Poteet, our mission pilot, is here with us in the spaces as well. I think we're just trying to designate him as one of the speakers, but he says hi.
All right. Thanks, folks. Yeah, let's dig in and start with a high-level summary of the Polaris program and Polaris Dawn as a mission and the objectives we're driving to. Jared, can you give us an overview of those?
Yeah, sure. I mean, just want to open up. I mean, this Spaces is really, it's really all about, the thousands of SpaceXers who spent the last 2 years working on some really, really awesome objectives that we're gonna share with you later today. I mean, they pretty much every day are making history, and we've got the next big milestone coming up on that awesome vision to make life multiplanetary. But just to zoom out for a little bit, talk on the Polaris program. So first, we named it Polaris after our North Star. which is actually a constellation of 3 stars. And as I think many of you know, the Polaris program contemplates up to 3 missions, culminating with the first crewed flight of Starship, which is kind of our North Star. That is showing us the way. May very well be the 737 of human spaceflight someday, but it's the planned vehicle to return humans to the moon and then on to Mars and beyond. But that's in the future. Let's drill in to Polaris Dawn, because that is the mission coming up. So just to give a quick overview of some of those objectives, and then each of my crew members will kind of go into a little bit more details. But it's a very ambitious mission. Our first objective is to travel farther from the Earth than the last time humans walked on the moon with Apollo 17, more than 50 years ago. So we target an apogee of 1,400 kilometers. That puts us just inside the Van Allen radiation belt. It's an awesome opportunity for us to get some data. But really, it's about kind of pushing beyond our comfort zone and where we've been at for the last 20 some odd years. At an awesome orbiting laboratory, the space station. But if we're going to get to the moon, Mars, and beyond, we gotta start venturing out a little bit farther. After about seven or so laps at our peak apogee, we'll come down to about 700 kilometers. And this is where the news of the day kicks in, and all the hard work from the SpaceX team to produce an EVA suit. And, really the first of its kind to be tested in more than 40 years in space. And we'll vent the cabin down to vacuum. And then we will undertake an EVA operation where we hope to learn an awful lot about our suits and the operation associated with it, because it's the first commercial EVA. It's the first time you don't have, government astronauts undertaking such a mission. And that's important because we are going to get to the moon or Mars someday. We're going to have to get out of our vehicles, out of the safety of a habitat, and explore and build and repair things. And that means the knowledge for spacewalks and EVAs has to go beyond just the few that it exists with today. Third, we're going to test out laser-based communication over Starlink. We have something super exciting planned for that. It's a really big deal. And that also is about the future of human spaceflight and reducing dependencies on, legacy ground stations or overburdened TDRS satellites, but to take advantage of laser-based communications to kind of open up this world for potentially hundreds of starships in the future. And then we have 5 days of science and research, about 40 experiments that our crew will talk to you about shortly. But that's the Polaris Dawn, and it's coming up really, really fast. It's back to you, Stu.
Thanks, Jared. Yeah, pretty badass mission profile. I want to start off with Starlink. It's humbling to think that we're going to leverage this incredible network of thousands of satellites that SpaceX launches, is growing, owns, and operates every single day on Dragon, our human-rated spacecraft. The constellation itself is going to talk directly to Dragon through the laser-based comms, as Jared mentioned. But I think Kid is on audio now. Wanted to hand it over to him to chat through how Starlink will be used on Polaris Dawn and some of the global outreach and objectives you all have.
Absolutely. Thanks, Stu. Apologies for missing the intro. I'm Kid Poteet, the mission pilot. Just briefly, background, 20 years flying F-16s, assignments with Thunderbirds, operational tasks, aggressors, weapons school, and combat tours. But as far as Starlink, this is an amazing objective we have set forth for this mission. As Jared had mentioned, the Polaris is a developmental program, and it's designed to help advance our quest for space exploration. However, based on what we learned and accomplished with Inspiration 4, we never wanted to lose sight of our priority to stay focused on improving life here on Earth. And that's exactly what SpaceX is doing with Starlink. It's a laser-based communication that's truly revolutionizing the way we communicate and connecting people from around the world to include remote locations. That's why we continue this partnership with St. Jude Children's Research Hospital. We had this unique opportunity to travel to other parts of the world, and through this collaboration, we brought them Starlink. It included hospitals and schools in the Philippines, Chile, Brazil, Mozambique, and these are providing services to the people of these countries that otherwise wouldn't have these resources. When we went to the Philippines, the hospitals, families that lived in very remote locations would have to travel hours just to get any type of medical care. Now we brought them Starlink, and they were able to connect with these remote locations, and they're getting telemedicine, medical consultations, diagnostics, procedures. They can continue this education while they're getting all this treatment. And they can stay connected with their families that are back in these remote locations. So it's it's absolutely amazing what SpaceX is doing with Starlink, and we're going to test that from space for the very first time. And stay tuned for how we're going to do that on orbit. But it's going to be exciting to watch for sure.
Thanks, Kid. Yeah, it's going to be incredible. Truly space-based internet used by people in space. We're excited to make that happen. Pivoting over to the research side of things, I know everyone refers to ISS as the orbiting laboratory, and it's incredible the amount of science and research that's done up there by crew year-round, every single day, 24/7. And we're excited to turn Dragon into its own orbiting laboratory. We did that on Inspiration 4. We're excited to grow the research program at SpaceX as we move forward and fly more people on Starship farther and continue to grow that industry. Anna, can you maybe chat through some of the research goals and activities planned for the Polaris Dawn mission?
Thanks, Stu. About 2 years ago, we put out a call for proposals all over the world to solicit research ideas to run on this mission, and we got back a ton of ideas. We ultimately down selected to about 40 research experiments, and we down selected based on technical feasibility, technical requirements, crew involvement, as well as the experiment's ability to take advantage of our unique mission profile. We are it's really important to us that we take advantage of basically every moment of time while we're in space. And so intermixed amongst those other ambitious objectives that Jared was talking about earlier, we will be filling our days with science and research. And I will highlight a few of the ones that we're really excited about, but there's so much to learn on this mission. So one is that we will be taking advantage of our flying at a really high altitude in order to better understand that radiation environment. While we are up there, we will be actually using a camera to try to harness the radiation environment and see if we can perform kind of an initial test of capturing X-ray images using that environment that we're sitting in. This could be super beneficial down the road if we're able to perform initial demonstrations. And if you envision, going to Mars one day, you would want to be able to have medical diagnostic capabilities that are small and really agile to support the humans living there. Other experiments that we'll perform are ones on space motion sickness. We will try to better understand what are the mechanisms and causes causing this. If you, when people fly to space, about 60% of people get afflicted by space motion sickness. And if you envision what that looks like, if you were to take a whole bunch of people into space, that means that a whole bunch of people could be sick and not feeling great during their initial adaptation to that microgravity environment. So if we're better able to understand this, we can make future astronauts' lives way better when they're going to space. And finally, another set of experiments we're really excited about is a group all focusing on spaceflight-associated neuroocular syndrome. We will be testing our eyes to better understand why vision problems arise in long-duration microgravity exposure. A lot of astronauts face vision changes after extended duration spaceflight. If you envision flying 9 months to Mars and you land there and you can't see well, you're not going to be able to work well. And so it's really important that we figure out what are the mechanisms behind this and better arm our future astronauts to do their work well in space.
Thanks, Anna. Yeah, it's going to be an action-packed 5 days up there, like Jared said. And I know the Van Allen belts and some of the radiation ties to the research that you all will be doing. But stepping back, can you also describe the unique trajectory and exactly where Dragon will be flying for this mission?
Definitely. So we will be essentially launching into a highly elliptical orbit where our perigee is at about 190 kilometers, but our apogee is at about 1,200 kilometers. We will then, after a number of orbits, be raising our apogee up to about 1,400 kilometers. And this is the highest that any human has flown in about 50 years since Apollo. And the benefit of being at this high altitude is that we can better understand the impacts of that environment, that higher radiation environment, for example, on both the human body, doing a lot of that research I mentioned earlier, as well as the spacecraft. After a number of orbits there, we'll complete all the research that we were intending to do, and then we will lower our apogee back down to a nice coasting orbit around 700 kilometers, where we will complete the rest of our mission objectives, including the spacewalk.
It's pretty amazing. Yeah, for folks that have been following along with SpaceX over the last few years, the Falcon team has done an incredible job of increasing performance of Falcon 9. And what we're doing here essentially is leveraging performance upgrades and truly using everything that Falcon can provide to Dragon to get it to the highest energy insertion orbit while still recovering the first stage. And then Dragon takes it from there, gets up to max apogee, and continues the mission down to the EVA altitude, and then obviously return to Earth for splashdown. Shifting gears to the EVA, so we've had to make a lot of changes to Dragon to facilitate an EVA. It's always possible for our traditional ISS missions that Dragon was built for to vent the cabin down to vacuum in a contingency. It was built for that case, but in the EVA, we're nominally taking the 4 crew members to vacuum for this spacewalk. So Sarah, curious if you can chat us through some of the modifications made to Dragon and really what it takes to make this happen.
Definitely, Stu. Yeah, you described it so well. There is a chance on a nominal NASA mission that the spacecraft could end up at vacuum in an emergency. But for this mission, we're intentionally taking the spacecraft to vacuum. And this comes with a whole set of challenges that the SpaceX team has been tackling over the last 2 years. Fundamentally, when Dragon was made, this kind of wasn't what the interior was designed for. And so there are so many different aspects that you need to consider when we don't have an airlock on Dragon. So in order to perform a spacewalk, we have to take the entire interior down to vacuum. So just from thinking through all the things on the interior, we need to now take a look at every material. As you start exposing things to vacuum, you're going to have things that off-gas. So you need to understand what all of the materials, literally everything in the vehicle, is going to do in that environment. I would say some of the big changes, though, are once we vent the atmosphere for the spacewalk, we also need to repressurize the spacecraft. So there's going to be a brand new nitrogen repressurization system that flies with us that will be used at the conclusion of the EVA to then repressurize the spacecraft. Similarly, in order to facilitate the spacewalk, we also had to go and assess what are all of the mobility aids and footholds that you need in order to actually be able to move and perform this spacewalk safely inside the spacecraft. So I think the interior is going to look a little different when you see pictures of us sitting in the spacecraft. There is some really, really cool new hardware, both mobility aids and this nitrogen system. But it's been a really integrated team effort to understand what the spacecraft is going to do when we expose the interior to vacuum. I think the maybe last change for mobility aids is instead of the beautiful cupola window that was flown on Inspiration 4, now we will have this, what we're calling the Skywalker, but a new structure outside the top of the forward hatch that allows a suited crew member to have a structure to interface with, almost handholds as you climb out the top of the spacecraft. But it's been really cool to see that hardware all come together in our flight spacecraft.
Yeah, the structure that'll be out front of Dragon as a mobility aid, we call it the Skywalker, as Sarah mentioned. It has to withstand a pretty extreme environment. It's close to the forward bulkhead Dracos that perform Delta V maneuvers, and so it gets hot during those burns. And then it also has to be able to withstand the cold of pointing if it's oriented towards deep space. So it's a metallic structure, but it also has a thermal barrier coating on it and is quite advanced to facilitate the mobility aid that the crew is going to utilize when they're out front of Dragon. Want to pivot over to the EVA suit itself. For every ISS mission Inspiration 4, every Crew Dragon flight to date, we produce 4 intravehicular suits that pressurize and keep the crew safe in case of a contingency. But it is a step change to go intentionally do that and go out into the vacuum of space, and the human themselves is looking at deep space or the sun or various thermal extremes. So Chris Trigg on the line, want to hand it off to you to talk through some of the modifications to the suit and really what it took to create the EVA suit revealed this morning.
Yeah, sure. So as you mentioned, Stu, we kind of started with the IVA suit that we have on our missions currently as our baseline and kind of took it from there. What would we need to change in order to support an EVA? And one challenge actually was to make sure that we kept all the functionality of the IVA suit in addition to adding the EVA capability. So we're using a single suit on the Polaris Dawn mission, so the crew will be wearing it out to the pad all the way through splashdown. So we wanted to make sure that everything the current IVA suit could do, we maintained that functionality, but then also made it EVA capable as well. So one big item out of the gate was mobility. We've done a lot of work on joints across the suit to make the suit more mobile now that the crew will be getting out of their seats and moving outside of the capsule onto Skywalker. So a lot of new joint design across the entire body. One of the joints that we worked really hard on are the rotators on the arms and the shoulders and the wrists, which allow the rotation of those joints. And they're unique in that when they're unpressurized, they stay soft and flexible so that during dynamic phases of flight, like launch or reentry, you don't have hard metallic objects that are kind of loading into the body of the crew members, but they stay soft. And then when you pressurize the suit, they rigidize it and give you that mobility that you need. Another big element was the thermal side of the suit. So obviously much larger thermal extremes that the suit will see when it goes outside of Dragon versus what it sees inside. So there was a lot of work on both the materials of the suit, developing a whole new layer that we needed to add for thermal management, as well as looking at the thermal condition for the crew members themselves and making sure that they were at a comfortable temperature inside the suit. And one thing that we added to their umbilical was a cooling knob that they'll be able to turn on or off to get cooling as they need it. Another big element was some added functionality in the helmet. Jared and Sarah will have cameras in their helmet, so we'll have a kind of first-person view of what they're seeing through their visor throughout the EVA. And then all the crew members have a HUD, a heads-up display in their helmet as well, which is displaying the real-time pressure, temperature, and humidity inside their suit, as well as a timer so they can keep track of the time of the overall EVA. And so those are just some of the bigger ones, but really a kind of total overhaul of the design when we got to the end of it here in terms of revisiting everything that we could to make the suit safer and more robust, given that we now know that we're going to vacuum for the EVA.
Thanks, Chris. Yeah, so with the new suit in mind, and obviously an EVA is an austere environment that you all will be going into. Sarah, can you explain to us, how do you train for an EVA?
That's a great question. I think, typically when you hear EVA, the first thought is build a pool. Use neutral buoyancy as a means of simulating the microgravity environment. We've been on, obviously, a much shorter development cycle, and putting a suit into the pool, it has its own challenges. And so the SpaceX team really approached it from a different and new direction of finding a means of doing that outside of water. And so we actually have at our facilities in Hawthorne, in our vertical capsule simulator, they figured out a way to put in a suspension system that has really cool controls, such that if you tap something with your finger, you move very similarly to what you would experience in microgravity. So picture a pressurized suit in a suspension system that can go through kind of the transition out of the spacecraft. But you're on suspension cables, and so you have those cables that would go through the hatch. So when we were starting to think through how do you train hatch operations, the team, over a weekend pulled together this incredible simulator that actually takes that and turns it on its side. So now you can suspend a crew member sideways and practice hatch operations in a very high fidelity microgravity environment simulation. So it's been a ton of fun over the last couple years to iterate with the team. The suit gets a certain change to it. We put that into our test facilities. We run the operation. We see what works or what we might need to change from a hardware perspective for mobility aids or from architecture changes to the suit. And it's been this really cool iterative test cycle over the last couple of years.
Hey, if Stu, if you don't mind, I just wanted to jump in on this too and give like a shout out to Chris Trigg and his whole suit design team. Chris just spoke before regarding the suit development, but I have to say, going back to like inspiration for when I first got introduced to SpaceX, I was like, they have all these ambitious goals. They're reusing rockets they catch on ships. They're trying to build spaceships to take us back to the moon or Mars. Why don't you just buy somebody else's suit? And then like maybe on the surface, you're like, well, it's like the aesthetics, looking very cool and inspiring about the future is important. And I'm sure there's a component to that, but like it's this vertical integration desire to like control all the pieces necessary to eventually get to that like self-sustaining kind of Mars civilization. And we were able to see it in practice over the last 2 years. I mean, just so cool from where we started to where we are now. And it's like all in-house, and every week or two you come back and Chris and his team, figured out a new joint or, a new approach to the visor coating or new ways to have redundancy on like the life support system. I mean, aesthetically it may look similar to the IVA, but what they did under the hood is extraordinary. And to do it in 2 years was only possible based on like SpaceX philosophies and what's in-house that Chris and his team oversee. It's just been like such a pleasure to watch. And really today's as an unveil is like a far bigger moment for you and your team, Chris, than it is for us who are fortunate enough to wear these suits.
Yeah, Jared, I really appreciate that. And obviously this has been really a dream project for the whole team. A lot of people here have worked on suits since really early on at SpaceX and got to develop IVA suits leading up to Demo 2. So it's been extremely exciting for all of us to get to kind of develop SpaceX's first EVA suit as well with the Polaris program.
Yeah, I want to pile on. Really great job to the suits team and Chris. I agree. It's been amazing watching this machine evolve over the last couple of years of development. But also want to point out it's an extremely multidisciplinary problem to create an EVA suit. The heads-up display that Chris mentioned, that was a project partnered with the avionics team within SpaceX. There's some pretty intense optical challenges to make that work and make sure the field of view is correct without blocking like the center of the suit. The coating on the visor for the EVA suit was actually partnered with some of the folks at SpaceX that worked to coat the cupola on Inspiration 4. It's a very similar spray process, and actually the same indium tin oxide coating is used on both the cupola and the EVA suit visor in order to get thermal correct there. So yeah, it's been an amazing project and journey there, and we're super excited to see this suit come to life during the Polaris Dawn mission. The last thing we wanted to touch on is just other crew training. Sarah talked a lot about suspended training and how we've trained for the EVA, but there's a lot of other aspects of this mission that we just walked through. And curious, Kid, if you can touch on some of the other training activities going into the austere environments that you and the crew have done over the last couple of years.
Yeah, you bet. And we kind of piled on to what NASA has done over generations as far as, identifying environments and situations that are stressful that we be able to deal with and learn not only strengths and weaknesses of your teammates, but learning about yourself and how you handle those stressful situations. So, for example, we've done scuba training, we've climbed several mountains, we've done skydiving, we fly fighter jets, and all these environments, they induce a level of stress that allows us to get comfortable in these uncomfortable scenarios. the fighter jets, for example, Jared and I will sit in the front seat, Nana and Sarah in the back seat, and we're working together as a team, going through checklist procedures, working on levels of trust, flying in close proximity to each other in formation. You're strapped into this aircraft, you're dealing with weather, all different types of scenarios. And it just allows us these opportunities to get comfortable together because these are similar situations that we're going to experience on orbit. And we got to be able to handle these stressful environments. Climbing a mountain, you're on the side of a mountain. It takes days to get towards the summit. You're dealing with dehydration, lack of sleep. Food's not that great, and you have this opportunity to learn a lot about each other as well as yourself. So those are some of the things that we've gone through. The centrifuge, the altitude chamber, put us in a similar environment, pulling G, slightly different axis, but similar nonetheless. All to prepare us, and we've done this over the last couple of years. We've had some great experiences, and we're just looking forward to putting it to the real thing come launch.
Thanks, Kid. I wanted to pivot over to some Q&A. We've pulled some questions off of X from the posts from earlier today, and then I believe the moderators are going to let certain folks in to ask their questions live. But to kick it off, I want to start with the pre-breathe protocol. So you obviously have to do a pre-breathe protocol before going down to lower pressure, pure oxygen in the spacesuit. Jared, can you explain what the pre-breathe is going to look like on Polaris Dawn, and why is it important to iterate on this and make improvements as we look towards the moon and Mars and beyond?
Yeah, sure, Stu. So I think best way to describe this is to think about a can of soda, right? So we have a lot of nitrogen in our system, and generally speaking, you add high pressure, you add more of it, and then you go to low pressure, it can come out of solution, and that's what essentially creates like the bends, or if for those familiar with like diving, or even worse scenarios. Now, this is not something new for our mission. This has had to have been dealt with high altitude flying like U-2, SR-71, or certainly all the EVAs on the International Space Station. Now, the difference, though, is that they will often just breathe 100% oxygen for a very prolonged period of time, or they can even do an exercise routine to try and purge the nitrogen from their system, in which case you have less concern about experiencing decompression sickness. Now, the problem is we don't have an airlock on Dragon, so we can't just sit in there for hours on end breathing 100% oxygen to rid ourselves of that nitrogen. We have to take a different approach to it. And the way that we do that over several days is we lower the pressure in the vehicle very slowly. And then we compensate by increasing, oxygen PPO2. So you're really, it's kind of like the equivalency of maybe like going to Denver or visiting like a mountain town. So it's not bad at all. But over that time period of being at what our body thinks is a higher elevation, we're slowly purging nitrogen from our system. And then we will switch to 100% O2 in our suits. For a period of time when we are venting down the capsule, and then we will conduct the entire operation at 100% O2. So it is interesting because in the long-term goal, like in the movies, of being able to throw on your spacesuit and helmet and just run outside and do an EVA, you have to account for this. And, this pre-breathe protocol that we're working with could help get us in a step in that direction if your entire mission was essentially in that environment. And then perhaps at some point you could just put on a helmet with 100% O2 and maybe go outside in a similar manner. So that's a pre-breathe. We've tested this all on the ground at a NASA chamber about a year and a half ago, actually under conditions that would be like worse than what's expected to be encountered from our pre-breathe and EVA, meaning that we have a bunch of safety margin built on top of it, and we know it works pretty well. Back to you, Stu.
Cool, thanks, Jared. Yeah, lots of modifications for that, but obviously important when we get to the moon and Mars. The goal would be that zero pre-breathe suit to be to be agile on a different surface, you have to just be able to put your suit on and go outside. And we're excited to take a step towards that with this pre-breathe protocol that works with the Dragon architecture. The next question is about the visor. So I briefly mentioned the indium tin oxide coating and how it was similar to what we used on the cupola on Inspiration 4. But we had a question earlier today about how it looks tinted. It definitely looks like an optical filter. Chris Trigg, can you walk us through how that was selected and kind of the iteration to get to the current visor design?
Yeah, sure. So the visor is serving a lot of functions. It's helping to seal the suit and retain pressure. It's obviously the optical porthole for the crew to see outside. It has to manage the thermal environment as well. And then, of course, it also has to protect, just like a pair of sunglasses, from preventing too much light and harmful wavelengths of light from entering the suit. So we iterated a lot, as Stu mentioned, kind of building on what had been developed for the cupola, which shares a lot of this similar technical challenges that was developed for Inspiration 4. And the tint of the visor is actually copper that is sputter deposited onto the visor. So we got to that by iterating through lots of different potential options, looking at not just the performance and making sure it met all of our requirements, but also thinking forward to what is something that we could scale economically in the future if we have to go make a lot of these. So that was something that, throughout the suit design, we were thinking about, and this is one example where it helped kind of drive us to where we got to with this copper-coated visor.
Awesome. Want to jump to some live questions. I believe the first person will be Felix from Spacetime. Are you let in? Seems like we're connecting right now. All right, Felix, looks like you're a speaker. You want to ask your question? How are you doing? No problem.
My name's Felix Gatfield with the Felix's Spacetime YouTube channel. So great to be able to talk to the crew again. Once again, thank you for taking my question. Creating a new spacesuit is no small feat. So a huge congratulations to the SpaceX team. As Jared said on X earlier today, it took 2+ years to get to this final product. I'm guessing there were many iterations before you got to this final refined product. What were some of the biggest design challenges along the way? Thanks again.
I think that's a great question. Chris, you want to start with that one?
Yeah, sure. I think one thing that makes all space hardware challenging, and certainly spacesuits too, is just the integrated nature of the number of problems that you're trying to solve. And so any one solution for a particular challenge may make another challenge more difficult. So the visor is a great example. You can adjust the tint of the visor to help your thermal considerations, but obviously that and then impairs the crew and their ability to see what they need to see. So you're kind of trading that back and forth. So I think the challenge on the suit was, because we approached it from the idea that like everything was fair game and we could go in and redesign anything if it made sense to go redesign it from where we were starting. You're often kind of having to review all of the different kind of challenges that you were up against and make sure that any one solution wasn't impacting the other one.
Cool. Yeah, thanks, Trig. Maybe another question written into X this morning. The spacesuit incorporates some materials from Falcon and Dragon hardware, furthering the collaboration across the company required to make this EVA suit happen. Chris, can you quickly talk through how it was working with those teams and what specifically we're utilizing from these other programs to make this soft goods suit happen?
Yeah, sure. So, we're here in Hawthorne, and it's pretty remarkable how many teams are under one roof. We build suits in the same building that we integrate Dragon, that we integrate Falcon. It's the same building that we do all of our vibe and thermal testing of avionics. So we have a lot of different resources at our disposal here, which is great. There's some thermal material that we ended up using on the boot, which was developed actually for Falcon and Dragon. It's used on the inner stage on Falcon and on the trunk of Dragon as well. We were kind of iterating through different materials, trying to thread the needle of the thermal requirements while being light enough to kind of wear. and easy to manufacture with. And the suit production team is located right next to where they actually integrate interstages. So it's a pretty funny story in that one day we were kind of walking and saw some of this material out, and immediately just started talking to the materials engineers on the interstage team, made some prototypes, and have now kind of gotten that material into the flight suits. So we'll be using that on the boots.
Awesome. Thanks, Chris. I believe we next wanted to bring in Will Robinson Smith, and we'll bring him in to ask a question. All right. Hey, Will, can you hear us?
Yes, I can, and thanks for taking some of our live questions. Really appreciate it.
No problem.
Wanted to ask about the development process, specifically with the wet versus dry testing. You mentioned sort of historically spacesuits go into a massive pool like the Neutral Buoyancy Lab at JPL or the Johnson Space Center. Was there a thought to do that type of testing with this suit at some point down the road, or has that already been done? And what's kind of the collaboration with NASA and some of the centers that you've been to? Thanks.
Yeah, I think that's a great question. Jared, you want to answer that with some of the training and trades that we made early on for EVA training?
Sure, and certainly welcome the rest of the crew to chime in. Look, that's what I thought was going to happen day one, right? I was like, this is just how you train for an EVA is underwater, so SpaceX better start digging a pool. And, good SpaceX fashion kind of zoomed out and said, is there a better way to go about doing this? Like, we certainly don't want to submerge our good Dragon simulator into a swimming pool. And we also need to work quickly and learn quickly. So they developed, as Sarah mentioned before, like the Argos type system of using an offloading hoist to replicate microgravity so we could conduct joint simulations and training environments in our simulator and do EVA work, essentially at the same time without putting anything into a swimming pool. Now, all that said, there's been a ton of collaboration with NASA from like subject matter expertise that have, provided inputs. We've had some NASA astronauts come out and observe some of our EVA training to provide input. That pre-breathe protocol that was tested in a pressure chamber over 2 days that I mentioned before was at JSC, and our ATP test, which is kind of the graduation exercise for these suits, where we go into a thermal vac chamber, will also be at NASA. So I think as much as we've done scuba training and practice in that environment, it really wasn't necessary for what we were trying to accomplish with this suit.
Yeah, thanks, Jared. I think maybe another way to think about it, to do underwater training, you actually have to modify the suit to facilitate that. You have to add mass to the suit to get it to truly neutral buoyancy. You also have to flow gas at a different flow rate because you're actually going to positive pressure. You're going to higher than 1 atmosphere versus just training in 1 atmosphere. We can flow at the standard just ground training that we use for pressurization and suit mobility testing. So the suspended training really was a simplification, and we went into it with an open mind. We want to make sure that you can test every single aspect of the EVA and every single motion that the crew has to make. And we created a checklist, and just like how you qualify a piece of metallic hardware by pushing and pulling on it in each different direction, we made sure we truly qualified the EVA operation and that we can demonstrate margin with the crew members doing the actual translation and hatch operations with certain pieces added on to make sure that when you actually get into the operation itself, that we're super confident that it will go as planned. Maybe to jump to another pre-asked question from X earlier today, Sarah, can you talk about how long will the spacewalk be, and what sort of activities are you going to do during it?
Sure. So the kind of, I don't know if this has been said explicitly, but the suits themselves are fed by the vehicle. So all of our life support is going to be coming from the vehicle. Oxygen tanks inside the spacecraft fed through an umbilical to our suits. The umbilicals provide, our electronics, our life support, and that is really our connection to the vehicle. We effectively have to fly all of those consumables. And so in order to both account for the full mission duration and make sure we can test this out, the operation is going to be scoped to about 2 hours end to end. And that includes venting the capsule, external operations, and then repressurizing the capsule as well. Outside the spacecraft, 2 crew movers will go through the kind of like a test matrix effectively to get SpaceX the data that they're hoping to see. And this is looking at mobility, movement in this microgravity environment, how the suit is performing. There's a kind of a whole series of test questions that will be stepped through for the time outside the spacecraft. But it'll be kind of the first opportunity. We have this ground validated system for training, but we're also equally validating that training method in the microgravity environment to see if there are nuances we didn't quite capture in our simulated environment. So getting all of that data to provide back to the SpaceX team for future EVA operations development and training.
Yeah, I think, Sarah, that's a super important point. The goal of this suit is to be our first design of the EVA suit. And then just like all other SpaceX products, we're going to continue through block upgrades as we go forward and learn. And so understanding the similarity between space activities during the EVA and ground training is very important, because we want to make sure that the ground training is validated and we can continue to make improvements and block upgrades and be confident that they're going to scale correctly when you get to a surface activity on the moon or Mars or other microgravity EVAs in Earth orbit. The next question is for Chris Trigg. Folks on X earlier today were curious. We now have our IVA product and then the EVA suit product, but is there a goal to make these EVA suits the standard flight suit, or what does that vision look like?
Yeah, so we definitely are working towards a point at which we kind of have a single suit architecture that's capable of all the things that SpaceX might want to do, wherever those missions may go. And so currently, as we've been talking about, we have this new combination EVA IVA suit, and then we have the standard suit, but that we fly on commercial crew missions. But we do plan to kind of merge and those designs and incorporate all of the things that we've learned in EVA suit development. And in fact, we've already started doing that, as I think our first mission was Crew 6 over a year ago now, where we introduced some changes to the IVA suits based off of things that we had learned and developed from the EVA suit program. And so we've already been kind of starting to do that and implement changes into our standard IVA suits.
Thanks, Chris. The next question wanted to go to Eric Berger, who is getting let in right now. Hey, Eric, looks like you're in. Can you hear us? Eric, can you hear us? It looks like you're a speaker now. All right, maybe while we're waiting for that, we can come back to Eric. We'll go to another question from X from earlier today. Folks wanted to know about the heads-up display. What does the HUD look like? Maybe, Sarah, you can chat through what the HUD looks like and what information are you all going to be monitoring during the EVA?
Sure. Yeah, I think I just love the heads-up display. It's such a futuristic part of this suit. Being able to have situational awareness about what your suit is doing when you're actually wearing it and outside the spacecraft. There's some kind of key pieces of telemetry we'll be looking at. The big and most important one is obviously your suit pressure. So you have insight into how it is performing, if pressure is holding and stable. And then there's some additional supplementary information like the amount of time you've spent on oxygen, so the timer keeping track of your allocation, and as well as temperature data and humidity in your suit. So it's kind of sits below your left jaw, and it's really cool. You can still see the world through the visor and through the display itself, but then you have those pieces of information available to you when you need them.
And hey, maybe to just jump in again, here is another awesome opportunity to, highlight the SpaceX performance here. Kit and I have flown aircraft with heads-up displays in them, and also, sadly, overseen efforts to try and upgrade aircraft with heads-up displays, and these are like 3-year efforts. So bear in mind, the SpaceX team built an EVA suit in less time than that. But I can tell you, we were in SpaceX, leaving on a Friday. We come back on a Monday, there's a heads-up display in the suits. Now, the first version of it didn't look anywhere near as sleek and refined as our current flight hardware, but they did it in a weekend. It was like a weekend project because they knew that we needed this type of information, so we could have good situational awareness when we're away from the displays and need insights into the health of our suits. And they continued to iterate on it until it's what it is today. But it's not hard to look out into the future on where this is going. Will it incorporate, checklists on more complex operations or EVAs years from now? Will it use augmented reality when exploring, perhaps another planet? It's pretty exciting. The seeds were planted not that long ago, and it's already, with respect to these avionics integrations into the suit, already moving in such a cool direction.
Thanks, Jared. It looks like Eric Berger's back in. Want to do a quick com check, and we'll let you ask your question.
Yeah, hi. Can you hear me?
Yeah, we got you. Go ahead.
Great. Sorry about that. I'm just wondering what the risk profile is, either for Stu or Jared, on this. You're obviously going to a higher altitude, so there's less debris, but you're MMOD risk presumably, but you're doing venting and an EVA. So I'm just curious, when you compare this to a flight to the space station, is this a higher risk mission? Is it about the same? Is it less? Just curious about your thoughts on that.
Yeah, Jared, you want to start with that, and then I'll fill in after.
Yeah, I mean, Eric, it's a good question. I mean, it's a different risk, and it's a different risk going returning to the moon. It's a different risk going to Mars. I mean, it's kind of the point. We've gotten really comfortable going from point A to B to an extraordinary, floating international laboratory. But I think humankind's ambitions are beyond that. So for sure, we're going to encounter different things than what we've had for up till now. There is far greater MMOD risk, at 1,000 kilometers, for example, and there is at 400 kilometers. But then there's an awful lot less of it when we start getting out there even farther. Certainly, the risk is different when you vent the vehicle down to vacuum and you're in a spacesuit than when you're not. But I think these are all positive steps, and again, in the direction of goodness towards humankind's interest to explore our solar system and beyond. So what I'd say is the SpaceX team is incredibly aware of these risks. You got 15,000 really bright people all focused on a common vision, and they know any missteps along the way can delay that grand goal. So we certainly are briefed constantly on where the differences are between our mission and a normal profile, and feel really comfortable they've been addressed.
Yeah, Jared, I agree. So maybe quantitatively to answer your question, we assess total radiation exposure, we assess total MMOD risk throughout the mission profile, and it specifically looks at the orbit you're in, the apogee, the perigee, the semi-major axis, what beta angle you're at, the pointing mode of the Dragon spacecraft, and we make sure it's within our risk tolerance. And so the Polaris Dawn mission for both of those will be within the risk that we accept for a 6-month ISS mission. And that's important to us. We want to make sure we're not unnecessarily taking risks, but you do have to expand the envelope and do it methodically. And that's exactly the purpose of this mission here. I will say maybe one anecdote. venting the capsule down to vacuum, as Sarah mentioned, is something only planned in a contingency for the original Dragon spacecraft design, and we've made modifications to facilitate that for Polaris Dawn. But one thing that we did last month was we sent the capsule to a vacuum chamber. We vented the vacuum chamber down and then vented Dragon through its vent system that it will use on orbit during the mission prior to the EVA. We sat there at vacuum for an hour to represent the time of the EVA. We were flowing pure oxygen through 4 spacesuit simulators and then pressurized the capsule back up using the flight repressurization system, the oxygen and new nitrogen repress system, as Sarah described. And that all worked as expected. The team got great data. And the way we were thinking about that is that's equivalent to the uncrewed Demo 1 flight that occurred before the crewed Demo 2 flight. We want to make sure we do the full scale end-to-end test before exposing the crew to those conditions. And ultimately, the successful test gives us the confidence we need to step into the mission. All right, that's all we wanted to cover for the Q&A. Maybe one last question for each of the crew members. I'd like to go kind of one by one and just let folks know what's the aspect of the mission you're most excited for. And maybe we'll start with Anna.
Thanks, Stu. Just first wanted to say thanks everybody for joining today. There is so much on this mission that I'm excited for. We have 5 action-packed days and hope to learn a tremendous amount to bring back to SpaceX and make future astronauts' lives better. But I think one of the many moments that I think stands out to me is an opportunity that I will have to read a book to my 2 kids from space, as well as some of the brave patients of St. Jude Children's Research Hospital. This book is raising money for the hospital, and I think it will be just a connection moment between our beautiful Earth and our crew in space that I will cherish and really remember.
All right, maybe Jared, what are you most excited for?
Yeah, sure. I have to tell you, I mean, I'm like Anna mentioned, like we have so much exciting stuff that we're looking to accomplish. But for me particularly, I'm really excited to see the reaction on my crew members' faces when we arrive into orbit. I'm going with 3 like incredible human beings that have worked so hard throughout their lives to get to this moment. And I know what a special feeling it is when that engine cuts off and you have arrived. And this time I'm going to be paying particular attention to my crewmates next to me just to take in that awesome moment.
Thanks, Jared. How about Sarah next?
I think I completely agree with Anna and Jared with so many moments to capture. You know, I think it is incredible to see what Starlink can do for the world with respect to connectivity. Seeing some of the hospitals we've been connecting around the world for St. Jude to bring their treatments, you know, to so many more kids around the globe is incredible. And the ability to, you know, use this network for such good. I'm really excited for getting to see what this can do for vehicles in space. You can kind of change functionality entirely for how you communicate with spacecraft with this high bandwidth capacity. So I think I'm personally really excited to share some moments from orbit with you guys over that path.
Thanks, Sarah. Kid, what are you most excited about?
Man, I struggle with this question every time we get asked because there's so many awesome, dynamic aspects of this mission that we're all looking forward to. You know, with 20 years of flying fighters, I'm definitely looking forward to the launch itself, going from 1G and 0 knots to 17,500 miles an hour, and you know, seeing what the Earth looks like. Especially at those lower perigees, cruising along, and then seeing Earth from 1,400 kilometers, and then you know just seeing what Starlink is going to provide via communication. We've been using ground-based facilities and teacher satellites for so long. we got high expectations for what Starlink can bring to the fight. And then lastly, the reentry and splashdown and reuniting with families. They've sacrificed so much over the last couple of years, and we definitely couldn't do it without the support of family and friends and the Polaris team, and obviously all the dedicated men and women of SpaceX. So it's going to be a great journey that we're going to share with the public.
Awesome. Thanks, Kid. Well, that wraps it up for today. Really appreciate everyone for calling in. We love the support. We obviously love what we do here at SpaceX and working on the Polaris Dawn mission here. And it's just exciting to release the EVA suit and talk about the mission and the suit design with all of you live. It makes everything worth it to have moments like this and then get ready for the mission and for sure go make history with this ambitious mission. The Dragon spacecraft for this flight is currently in Florida. It's going through its pre-launch processing phase, and the hardware is moving forward and on track for that early summer launch. Really wanted to thank the Polaris Dawn crew, Chris Trigg, everyone from the SpaceX side for joining and talking through this today. And yeah, overall, really excited to make history for the Polaris program, take a huge step for SpaceX and the industry as a whole. And thanks everyone for calling in.
Thank you.